This is the problem. A hollow steel shaft of 300 mm external diameter and 200 mm internal diameter has to be replaced by a solid alloy shaft. Okay, assuming the same values of polar modulus for both, calculate the diameter of larger and work out the ratio of their torsional rigidities. Take C for steel as 2.4, C for alloy. Oh. This is very good question, I must say. So let a solution, let the solution begin. So we have to note it down what values actually given. Okay. So given data are external diameter of the shaft, which is denoted by, as you know, D is equal to 300 mm. Okay, internal diameter of the shaft, which is denoted by letter D, is equal to 200 millimeter mm. Modulus of rigidity, which is denoted by CS, is equal to 2.4 as per the question, where Ca is the modulus of rigidity for alloy. Okay, so take steel C as CS, 2.54 as alloy. So Ca and Cs. Okay. Now diameter of the solid alloy shaft. Now diameter of solid alloy shaft, let us take as D1. So diameter of solid alloy shaft is equal to, let us take D1. Okay, so we know polar modulus of hollow steel shaft as, so as we know polar modulus of hollow steel shaft, mind it, hollow steel shaft, we can derive it by this formula. Zs subscript s is pi by 16d d to the power 4 minus d to the power 4. You know what is capital D and what is letter D. Now let us simplify it. Pi divided by 16 into the value of D is 300, and this value are as like 300 to the power 4 minus 200 to the power 4 mm cube, right? Now similarly polar modulus of solid alloy shaft, so polar modulus of, for, let me write it as, for solid alloy shaft, solid alloy shaft as ZA pi by 16 into D1 cube mm square. Right? Now, since polar modulus of both the shaft are same, therefore we can equate, if we name it as equation number 2 and if we name it equation number 1. So we can equate this equation number 1 and 2. We can equate equation 1 and 2. So from here we can write it down as, if we simplify these terms, we can directly write it as 8.125 into 10 to the power 6 pi divided by 6 is equal to pi by 16 d1 cube. So from here we can evaluate the value of T on Q as 8.125 into 10 to the power 6 into 16 divided by 6, which will give us the result of 21.67 into 10 to the power 6, right? So from here we can have the value of T1, which is the 27.8 mm. Okay, so what we are asking to find out, that is the diameter of larger मतलब value है. So D1 is more than enough. Now if we further want to find out the ratio of torsional rigidity, it is the answer of first part of the problem, mind it. Now if we wish to find out as per the problem the ratio of torsional rigidity, ratio of torsional rigidity, torsional rigidity. So we know the torsional rigidity of hollow steel shaft as torsional rigidity of hollow circular steel shaft is, so torsional, sorry for the interruption, so torsional rigidity of hollow steel shaft is equal to Cs into Js, which will give us the value of 2.4 Ca into pi by 32 300 to the power 4 minus 200 to the power 4, right? And torsional rigidity of alloy shaft, for alloy shaft, for alloy shaft the value will be Ca into Ja is equal to Ca into pi by 32 into d to the power 4, which will give us the value of Ca into pi by 32 into 278.8 to the power 4. This is equation number 4 and the previous is equation number 3, right? Now the ratio, so if we find out the ratio, that will be torsional rigidity of hollow steel shaft and torsional rigidity of hollow alloy shaft. What will be the value from equation number 3 and 4? That is 2.4 Ca into pi by 32 300 to the power 4 minus 200 to the power 4 divided by Ca into pi by 32 278 to the power 0.8 to the power 4, which will give us the value of 2.58. So ultimately the ratio is 2.58. So here is the conclusion of the problem, right? So we will see you with new topics from the next class. Thank you for your attention. Thank you.